This is the second part. We're just going to do two examples here, talking about finding the location of the asymptotes as well as the domain and range for each one of these tangent functions. So we have the same idea here as we've had with the other functions. We have an a value. This is going to, it won't be the amplitude because tangent, as you can see here, it's not, there's no cap on it, right? It's going to go up to infinity and down to negative infinity. So it's the a value is going to make it jump either more quickly or slowly to infinity and negative infinity. If the a value is negative, that will have the same effect. That will reflect across the x-axis. So we still have our b value, our h value, and our k value. That will be the same in terms of horizontal shift, vertical shift, and then affecting the period. Okay, so for this one, we do have this 2 in front, which is saying it's going to stretch it a little more vertically. And then the one we're really interested in is this minus pi over 2. So we're actually going to have a horizontal shift, and this is going to move to the right pi over 2. This is going to move the whole graph down, okay, down 5. So that's similar in terms of what we're doing here. Now, the b value in this case is 1. So I'm going to say b times the p, or period, is equal to 1 pi because it's tangent. So the period times 1 is pi, and the period is just pi. Okay, so period is the same. This pink highlight is the just regular y equals tangent of x, nothing fancy, nothing, no parameter changes, nothing. So this shift to the right is what we're really going to focus in on. So let's try here. What color do we want? Orange is not the best. I kind of ran out of colors. Let's go orange. Okay, so instead of this anchor point being here, we're going to move it to the right, pi over 2, and we're going to move it down 5. So here's my new anchor point, and it's actually going to be right along this, what used to be a vertical asymptote. Now, the period is pi, which means I'm going here to pi, because that's halfway, right? Half a pi, and here's half a pi. And this is how my graph is going to look. Now, this is a very rough sketch. We'll learn how to actually graph these, so not to worry right now. The biggest thing we want to concentrate on is where the heck are these asymptotes? So we're going to say location of asymptotes is x equals, I'm just going to go with the y-axis. So x equals 0 plus pi k, where k is an integer. Now we could have used this and said x equals pi plus pi k. We could have used negative pi plus pi k. 0 is probably the simplest because we actually don't even need the 0 at all. We can just say x equals, and this is what you'll normally see, just x equals pi k. And then any integer you plug in for k, that is going to be your location of the vertical asymptote. Okay, the next thing is the domain. So the domain is which values can I plug in? And if we look at this orange curve, that's going to repeat every 1 pi, right? We can plug in anything we want except for the asymptotes. So you're going to say all real numbers where x is not equal to pi k when k is an element of the integers. That's your domain. Your domain is any real number you want except for where the function is undefined at those vertical asymptotes. The range is the most boring. This goes up to infinity, down to negative infinity. It is all real numbers for those outputs. And that's it. All right, let's take a look at one more question. Okay, so for this one, our b value is 2. And this is telling me I'm going to go to the left pi over 4, and I'm going to go up 1. All right. Again, let's think about no parameter changes, and let's see how we're going to change things up. So with no parameter changes, we had our vertical asymptotes here and here, and we had a graph that looks like this. No parameter changes. Now it's saying, hey, you're going to move to the left pi over 4 and up 1. So let's pick blue for this new situation. We're going to move to the left. So instead of this anchor point here, we're going to go to the left pi over 4 and up 1. Okay, now we definitely need to find out what the period is going to be. So let's find that out. PB equals pi. The period times 2, the v value, is equal to pi. And so the period is pi over 2. Okay, pi over 2. Here is my anchor point. If the whole period is just a half pi, that means I need to go to the left and right 1/4 of a pi. And look at this, actually is going to be the same vertical asymptote, but this is going to be the vertical asymptote here. And in the whole space between these two, we're going to see that that's a distance of 1 pi. Look what's going to happen. Here's the next spot, right? We're going to go a half pi, and then our graph is going to look something like this. Again, don't worry so much about the graphs right now, but this will keep repeating over and over and over. So the blue is really what we're looking at, and this is the function that we are talking about. So the only thing we really have to know is where are those asymptotes located. So we can say location of the asymptotes, x equals, I'm going to do this one. I'm going to look right here. X equals negative pi over 2 plus, now, how do we get to this next one? I have to add a half pi, where k is an integer. Now, this is totally correct. This would start me here at negative pi over 2, and then I would add a half pi either direction, and I would be able to get all the vertical asymptotes. Now, I would personally start again at 0, and I would just say, hey, the vertical asymptote is pi over 2k, where k is an integer. So this is what I would have written. But you can honestly start anywhere and just add that period. And that's what I did here. Pi over 2 is the period. The domain, again, is all reals where it's not undefined. So where x is not equal to the vertical asymptotes. Pi over 2k, where k is an integer. And then we have our boring range again, which is all real numbers. So we will work on the actual graphing. Right now, we're just going to think about how are things changing that anchor point? Where are we moving it to? What's the period? And find out what those